All right, welcome back to the deep dive.
Hey there.
Today we're tackling a really specific challenge in Java programming. It's got this cool name, the diamond problem.
Hmm.
And our mission really is just to cut through all the dense technical stuff you might find online.
Yeah, distill it down.
Exactly. Pull out the core ideas so you can get a handle on it pretty quickly without feeling, overwhelmed.
Right. We're basically going to look at why this problem exists in the first place, especially in Java,
Uh-huh.
how Java deals with it, which is quite clever, actually, and, what it means for you when you're writing code.
Whether you're just starting out or maybe you've hit this already.
Exactly. It tells you a lot about Java's whole philosophy.
Okay, so let's just jump right in then. The diamond problem. What is it, fundamentally?
Well, it's a known issue in object-oriented programming, specifically for languages that allow multiple inheritance.
Meaning a class can inherit from more than one parent class directly.
Precisely. And the name diamond comes from how it looks if you draw it out.
Oh,
Imagine you have Class A at the top. Then Class B and Class C both inherit from A.
right.
And then, down at the bottom, Class D inherits from both B and C. See? It forms a diamond shape.
I see it, yeah. A, then B and C side by side, then D connecting below them.
Exactly. Now, the problem happens if there's a method defined in A, let's say do something,
Okay.
and both B and C override that method, maybe doing slightly different things.
Mm-hmm.
Now, Class D inherits from both B and C. So, which version of do something should D use? B's version or C's version?
It doesn't know it's ambiguous.
That's the core of it, ambiguity. Which implementation is the right one?
Okay, that makes sense for languages with that kind of multiple inheritance.
Yeah.
But what's really interesting, as you hinted, is why we're even talking about this in Java. Because Java famously doesn't let a class extend multiple classes, right? It avoids that classic diamond shape for classes.
Exactly. Java sidestepped that specific problem from the get-go by saying, nope, only single class inheritance.
So where does the diamond reappear?
It came back sort of through the side door with Java 8, specifically with default methods in interfaces.
Interfaces. Right. A class can implement multiple interfaces in Java.
Correct. And before Java 8, interfaces only had method signatures, just the names and parameters, no code, no implementation.
It were just contracts, blueprints.
Pure blueprints, yeah. But Java 8 let us add default implementations inside the interface itself.
Which was useful for evolving APIs, right?
Yeah.
You could add a new method without breaking everyone who already implemented the interface.
Huge advantage for backward compatibility. But here's the catch. What if your class implements interface B and interface C?
Okay.
And both interface B and interface C provide a default implementation for the exact same method signature.
Uh-oh. There's the diamond again.
Yeah.
The class has two different default implementations available. Which one does it pick?
Bingo! That's the Java version of the diamond problem. It's specifically about conflicting default methods from multiple interfaces.
So it's not something developers, try to create. It's more a potential side effect of complex designs.
Absolutely. You usually run into it in larger systems, maybe frameworks or libraries, where you have deeper interface hierarchies for things like, logging or event handling.
Right, where you might be combining capabilities from different places.
Exactly. And understanding it is key because it shows you where conflicts can happen and, more importantly, how Java forces you to resolve them to keep things predictable.
Okay, so Java 8, default methods. That's the trigger. How exactly did that make it so relevant? And crucially, how does Java stop it from being a total nightmare?
Well, like we said, before Java 8, interfaces were just those abstract contracts. Default methods gave them teeth, gave them actual behavior.
Made them more like abstract classes in a way.
Yeah.
But you could implement many of them.
Sort of, yeah. It mimicked some aspects of multiple inheritance or traits from other languages, and that power needs rules. Java's approach is really about design clarity.
How so?
By forcing resolution at compile time, it makes you think about your interface design. Is this hierarchy getting too complex? Is there a clearer way?
So it's not just about fixing an error, but encouraging better design.
I think so, yeah. And it's super relevant in modern Java. Think about things like the Strings API or GUI frameworks or systems with plugins. They often rely on multiple interfaces working together.
Right. You need to know how these potential conflicts are handled. It's not a feature to use, but a challenge to manage.
Precisely. It's about preventing ambiguity and making sure the code does what you think it does.
Okay, let's connect that to the internals then. How does Java actually enforce this? You mentioned compile time errors.
Right. So internally, the compiler looks at the class, let's call it my class, that implements interface B and interface C.
Mm-hmm.
And let's say both B and C have a default void to work method. The compiler sees this direct conflict. It knows my class has two competing do work implementations available.
And it just stops.
It stops and throws a compile time error. It basically says, hey, I see two different default do work methods here from interface B and interface C. I don't know which one you want. You need to tell me.
It forces the developer's hand.
Completely. It refuses to compile until the ambiguity is resolved. This is key. Java prioritizes preventing runtime surprises over maybe trying to guess or having some complex implicit rule.
So it doesn't just pick one based on, like, alphabetical order or something silly.
No way. That would lead to chaos. It demands explicit instructions.
That feels very Java. Strict but safe.
That's a good way to put it. Compile time resolution is the cornerstone. It forces clarity before the program even runs. Then, once compiled, the JVM just uses the resolve method consistently.
Okay, I remember the first time I saw that error. It was confusing, like, what did I do wrong?
Yeah.
But thinking about it now...
It's actually helpful guidance.
Yeah. It prevents those horrible runtime bugs where something behaves weirdly and you have no idea why.
Yeah.
So what are the big upsides, the advantages of Java handling it this way?
The biggest one is definitely that clear resolution mechanism. No guesswork, no hidden rules deciding which method runs. Predictable behavior.
Compile time safety, catching it early.
Absolutely. It prevents a whole class of runtime errors that could be really subtle and hard to track down otherwise.
Right.
And it still gives you that flexibility with interfaces. Default methods let you evolve libraries and APIs without breaking everyone's code. Java's rules just manage the potential conflicts that arise from that flexibility.
So it supports more modern design patterns, too, like adding common utility methods to interfaces.
Yeah, exactly. Things that feel a bit like traits or mix-ins in other languages. You can add reusable code directly into interfaces, which can lead to cleaner designs and frameworks, for example.
And it encourages, or maybe forces, developers to think more carefully about their interface designs.
It does. You can't just slap interfaces together haphazardly if they have overlapping default methods. You have to be deliberate. It's like Java's being a strict referee.
Making sure the rules are clear before the game starts.
Perfect analogy. Clarify conflicting rules up front to ensure smooth play.
Okay, that sounds pretty solid. Yeah. But you mentioned it's not always easy. What are the hurdles? Where do developers, especially maybe newer ones, stumble?
Well, the main one is just dealing with that ambiguity when it crops up. You have to manually resolve it.
Which means writing extra code in your class.
Right. You either need to write your own version of the method in the implementing class, overriding the defaults entirely, or you have to explicitly choose which interface's default method you want to use using that special interface name .super.method name syntax.
Which can look a bit weird if you haven't seen it before.
It can, yeah. And if you have really complex interface hierarchies, interfaces extending other interfaces, it just increases the chance of these conflicts popping up.
Making design and maintenance trickier.
Definitely. Adding a new default method to an interface later on could suddenly introduce conflicts in classes down the line that you didn't anticipate.
Ouch. Requires careful testing.
For sure. And those compile time errors, while helpful ultimately, can be intimidating at first. It's just another concept to get your head around, especially when you're also learning lambdas, streams, all the other Java 8+ features.
It adds to the learning curve.
It does, but again, I'd stress that Java is being strict for a good reason. It's trying to save you from much worse problems later on.
The strict but helpful parent analogy again. Clean your room now.
Exactly. Avoid the bigger mess later.
Okay, so let's nail down the specifics.
Yeah.
How exactly does Java solve it? What are the concrete rules the compiler uses?
Right. There are 3 main rules the compiler follows to resolve things or force you to resolve them.
Okay, rule 1.
Rule 1 is what we've been talking about. Explicit conflict resolution. If a class implements 2 interfaces, say INTFB and INTFC, and both have a default method did work, the compiler throws an error unless the class does one of 2 things.
Override it.
Either override did work with its own implementation,
or
explicitly call one of the defaults using intfb.super.dowork or intfc.super.dowork inside its own dowork method. It must choose.
Okay, makes sense. Demand clarity. What's rule 2?
Rule 2 is the class priority rule, sometimes called class wins. If a class inherits a method from its superclass, like extends my base class, and also implements an interface with a default method of the same signature, the The method from the superclass always takes precedence. The interface's default method is essentially ignored in this case.
Ah, so inheritance from a class is stronger than a default from an interface.
Exactly. No ambiguity there. The class implementation wins.
Got it. And rule 3.
Rule 3 handles interface hierarchy. Let's say interface CC extends interface B, and both provide a default implementation for do work.
Okay, so one interface inherits from the other.
Right. If your class implements interface C, which default do work does it get? B's or C's?
I guess the more specific one, C's.
You got it. The default method in the most specific interface, the one lower down in the hierarchy, interface C in this case takes precedence.
Okay, that feels intuitive. The closer implementation wins.
Pretty much. And all of this is checked and enforced strictly at compile time, no surprises.
It really is like a well-defined rule book. Decide or class wins or most specific interface wins. Clear steps. So boiling this all down, for someone listening, maybe they're newer to Java 8 Plus features, or they just want to be sure they've got this straight. What are the key takeaways? How do you navigate this effectively day to day?
Okay, first, just be aware that default methods exist and that they can lead to this diamond problem if you implement multiple interfaces with overlapping defaults.
Know the potential pitfall exists.
Right. Second, be prepared to resolve conflicts explicitly. Don't be scared by that compile error. It just means you need to either override the method or use that interface name.super.method syntax.
I like the choice.
Third, especially when you're learning, try to keep your interface hierarchies relatively simple. Don't go overboard with default methods unless they provide real reusable value and are unlikely to clash.
Keep it simple. Good advice generally.
Always. Fourth, when you are designing or working with interfaces, maybe sketch it out. Just mentally map it. Does this setup create a potential diamond? Checking ahead can save time.
Proactive thinking.
Fifth, really use those compiler errors. Read them carefully. They usually tell you exactly which interfaces and methods are conflicting. They're guiding you to the solution.
Treat the compiler as a maybe slightly grumpy assistant.
Yeah. Sixth, look at how established frameworks use default methods. The Java Stream API, for example, or libraries like Spring. Seeing them in action can make the concepts clearer.
Learn from the pros.
And finally, always test thoroughly, especially if you add or change default methods in an interface. Make sure that implementing classes still behave as expected.
Test. Makes sense. Anything else? Maybe looking ahead.
Well, as you get more advanced, you might explore newer features like sealed classes and pattern matching introduced in later Java versions like 17. They offer even more ways to control and understand your type hierarchies, kind of complementing what default methods started.
Okay, lots to keep in mind there. But the core rules seem clear. So we've really gone deep into this diamond problem in Java today. And it's clear it arises specifically because of default methods in interfaces, allowing a class to inherit conflicting implementations.
Right, it's Java 8's specific flavor of the problem.
And Java's solution is strict. Prevent multiple class inheritance entirely, and for interfaces, demand explicit conflict resolution at compile time.
Yep. Safety and predictability over implicit magic.
Even if it means a bit more upfront thinking or coding for the developer sometimes, it's a deliberate trade-off.
Absolutely. It's a fascinating case study in language design, preventing runtime ambiguity by being very clear during compilation.
It really highlights that balance, doesn't it, between giving developers power and flexibility and maintaining clarity and preventing chaos.
It certainly does. Java leans heavily towards clarity and safety in this instance.
So thinking about that Java's strictness here, demanding explicit choices to avoid ambiguity, it makes you wonder, where else maybe in other areas of programming or even, completely outside of tech, could we benefit from a similar philosophy? Forcing clarity up front to prevent confusion or unintended consequences down the line.
That's a great question. Plenty of areas, I suspect.
Something to definitely chew on.